Welcome builders to Kellenberg Robotics' final Fusion 360 video that I'm going to be posting as captain of the robotics team. In today's video, I wanted to show something that is not really shown in such detail, and that is the scissor lift design. Here are some reference videos that I recommend watching if you have no idea even where to start. Kepler Electronics has the ultimate guide to bar lifts. He has multiple videos, but this is a 6-bar and 4-bar lift tutorial. He basically showcases how you can build it very quickly. Also, Pyrotech's guide to building a scissor lift is a short 2-minute video with a lot of time lapse as he goes over his explanation of building the scissor lift model that I actually decided to make in today's video instead of the 4 or 6-bar lift. Those videos will be linked in the description below. This design was inspired by different sources that I combined together to create my own model. It takes a linear slide with 2 motor inputs and pushes the 6-bar scissor lift up in a vertical motion. I also turned in display settings, object visibility, sketches and joints off so that it's easier to look at this build. So I started off with the left chassis. This is not going to be an in-depth tutorial. It's going to be a showcase to every single part that has to do with the scissor lift of my design. Isolating the chassis, we have 6 outer acetal slide trucks lined up like this, and I found out later that there is going to need to be a spacer of 0.0625 inches, so that way the gear on the motor train will line up with the slide. Before I go on, I want to show you spacers that I compared here. I have 3 separate spacers. One is the high strength shaft spacer that is 0.0625 inches in height. Then I also have a steel washer that is 0.032 inches in height, and a steel washer that is 0.016 inches in height. So basically, to get this high strength shaft spacer, you either need 2 1:32 steel washers or 4 1:64 steel washers. So keep that in mind when if you're going to be replicating this build. Back to the chassis, we also have a gearbox bracket that is extended with 2 standoffs at 0.75 inches. That was also added on later because I found out that the height of the slide to the chassis is 0.75 inches. You want both gearboxes to be leveled so that way when the scissor lift lifts, it will be balanced and lifts properly. Moving on, this is just a rail with rack gear pinions, 4 here, and then 1 inner acetal slide to hold the gearbox in place. The next thing I decided to work on was the motors. So I wanted 2 motors powering from a 12-tooth gear, and I attached it to a 3-wide C-channel that is 5 holes long. And also you can extend it further if you want a larger gear ratio. And the last thing I worked on, which took me an extra 4 hours after 8 hours to add up to the 12 hours, is the scissor aspect itself. I started off by making each bar for the scissor lift. So basically you have a 2-wide C-channel, 35 holes long, and you put a bearing block at either end and directly in the middle. Create joints that are revolute. Every other joint so far has been rigid. If we go into the edit joint limit, when it's a revolute joint, you have a minimum and maximum degree, and the rest option is where it will return back to. So the minimum degree I want it to be is 10 degrees, and the maximum is 75 degrees. And then when you finish your bar, all you have to do is create one last rigid joint to the gearbox. And then to make sure that it aligns on both sides of the gearboxes, you want to figure out the distance from this gearbox end to the other gearbox end. And I found that to be 0.125 inches. So that's the offset I have here. I didn't add in the screws here, but I know when I'm going to be in the lab, that is what's going to be added. And you need a spacer or washer to fill the gap so that they do not rub. So that is the entire one side of the scissor lift done. All you have to do is replicate this for the other side and attach it to a chassis, such as the one that I made in a previous video. And you have yourself a working robot chassis with a scissor lift. I hope you guys all enjoyed the videos that I have been making over the past year for Kellenberg Robotics. You can also use it not only for Vex Robotics and its kits, but you can also create your own sketches with your own parts and even create your own machines. So I'm excited to see what you guys will be making in the future. But on that note, I wish you all the best of luck, and I'll see you in the final video. Peace.